What is model collapse? Welcome to The Explainer. Today, we are diving straight into a looming digital mystery that is literally reshaping the future of artificial intelligence. Think about it like this. Imagine taking a stunning, beautifully crisp, high-resolution photograph, and then making a photocopy of it. Okay, looks pretty good, right? But then you take that photocopy and you copy it again, and again, and again. With every single generation, the sharp contrasts start to blur out, the fine textures smudge, and those unique little details simply vanish into a muddy wash of gray. Well, we're currently witnessing this exact phenomenon right now, only not with ink and paper, but with the very fabric of human knowledge in the digital age. So, formally, what exactly is model collapse? And more importantly, how does it fundamentally threaten the massive generative systems we are spending billions to build? Okay, let's dive into this. For years, these massive AI systems, from large language models to image generators, have been training on a sprawling, wonderfully messy, endlessly fascinating dataset, the internet. They just gobbled up billions of words and images created by real humans. But a fundamental shift is happening right now. The internet is rapidly filling up with synthetic data. AI-generated text, images, and code are completely flooding the web. Which means that when developers go out to scrape the internet to train the next generation of AI models, they weren't just scraping human output anymore, they're scraping AI output. To really grasp what happens next, think of an AI model as a copier of light. Generation 1 trains on human data and produces a remarkably good approximation of our world. Fantastic. But then, Generation 2 comes along and trains on a mixture of human data and the synthetic exhaust left behind by Generation 1. Then, Generation 3 trains on the exhaust of Generation 2. As new models train recursively on the outputs of previous models, the fidelity of the data just starts to degrade. The copier is essentially printing worse and worse copies. And listen, this isn't just some theoretical worry. It is a rigorously documented scientific phenomenon. Groundbreaking research by Shumilov and their colleagues formally identified this exact issue as the curse of recursion. They actually proved that using model-generated content in training causes irreversible defects. It acts almost like a digital infection, where the models literally begin to forget the original distribution of the data. And the wild part? They proved this happens across the board, whether we're talking about variational autoencoders, Gaussian mixture models, or the huge large language models we use every day. And this brilliantly illustrates exactly how that forgetting happens. You see, we have to look at the statistics. Data follows a distribution. Right in the middle, you have your high probability center. That's the most common, predictable information. But on the edges, you have the tails. The tails are where the variance lives. It's the minority data, the rare words, the uncommon syntax, the weird, messy, beautiful human details. But because AI models are fundamentally prediction engines, they naturally oversample that high probability center. So when models train on the outputs of other models, they just double down on the center. As a result, all those rare human details out in the tails get completely washed out. It gets even crazier. Another major study by Alama Mohammed and their team gave this self-consuming loop a truly chilling name: model autophagy disorder, or MAD. You can basically think of it as an AI version of mad cow disease. Seriously. Just like feeding cattle the remains of other cattle led to a catastrophic prion disease, feeding a generative system its own synthetic outputs leads to a progressive compounding degradation. Without enough fresh, real human data, future generative models are mathematically doomed to have their quality and diversity progressively decrease. Without enough fresh, real human data, future generative models are mathematically doomed to have their quality and diversity progressively decrease. But what makes this so incredibly dangerous is how it actually begins. The first stage is known as early model collapse. And honestly, it is so hard to spot. Why? Well, because as the model begins losing information about the tails of the distribution, as that weird minority data drops out, the outputs initially just seem smoother. The rough edges are sanded down. Performance might even briefly appear to improve or become more consistent. But that smoothness is a mirage. It's masking the fact that the model is actively losing its grip on the full richness of reality. Then the tension really builds as we enter late model collapse. The model begins to lose a massive proportion of its performance. Lexical, syntactic, and conceptual diversity just absolutely plummets. Those rare words vanish. Complex sentence structures are totally abandoned. The creative well runs dry, and the model's outputs become drastically emptier. What you're left with is basically a hollowed-out shell of its former self. Sure, it's capable of producing text or images, but it lacks any underlying variety or substance whatsoever. Finally, we hit total collapse. It is literally like a robot watching its own face degrade in a mirror. The learned conditional distributions concentrate all their probability mass on a tiny, incredibly narrow subset of continuations. The model loses its variance entirely. It starts confusing basic concepts. And it doesn't just become less creative, it becomes completely tethered to highly predictable, flawed outputs. It becomes wrong over and over again in the exact same ways. But it's worth noting this isn't a settled apocalypse. The scientific community is actively debating the real-world impact of all this. Some researchers are ringing the alarm bells, warning this could fundamentally threaten the future of generative AI. However, others argue that model collapse can be mitigated. They suggest that if we use machine learning detectors and watermarks to filter out the synthetic data, or, crucially, if we simply accumulate fresh, real human data alongside the synthetic stuff over time, rather than replacing it entirely, we might just be able to break the curse of recursion. But regardless of the technical workarounds, the phenomenon of model collapse forces us to confront a pretty profound reality about the technology we are building. The internet was once this pure reflection of humanity, right? But it is rapidly becoming a hall of mirrors, just reflecting our own algorithms back at us. Which leaves us with one sharp, unavoidable question. If the training set is mostly the last model's answers, who is left to teach it the world?
If you enjoyed this video, please like, comment, and subscribe for more AI and technology content. Thanks for watching.